In the last two videos, we looked at the quotient of a powers property and the power of a quotient property. And those are the two properties that we're going to use working with these examples. So if you didn't watch those, I would suggest going back and watching those before this one so that you can learn the different properties. But in this one, we'll just look at some examples. So 5 to the 6th power divided by 5 to the 3rd power. Well, we learned from the properties that when you have a quotient of powers, so you have two numbers that have exponents and they have the same base, the easiest way to solve that is to rewrite the base and then just subtract the exponents. So we'll rewrite the base, which is 5, and then we'll take 6 minus 3. So we subtract the exponent. So 6 minus 3, and we get 5 to the 3rd power. Now you could multiply that out, or you can leave it like that. It depends on what the question's asking for. If you multiply it out, it would be 5 times 5 times 5, which would be 5 times 5 is 25, and then 25 times 5 is 125. So either answer should be okay, depending on what the question's asking for. Okay, the next example, 3 to the 3rd power divided by 3 to the negative 4th power. So we notice they have the same base, so we can write 3 to the 3rd power minus a negative 4. So since it's a minus a negative 4, that's actually 3 plus 4. So that's going to give us 3 to the 7th power. And that'll be the answer for that one. Okay, this next one, we have 8 cubed times 8 squared divided by 8 to the 5th power. Well, let's simplify the numerator first. 8 cubed times 8 squared. When we have multiplication of powers, all we have to do is add the exponents as long as both powers have the same base, which in this case they do. The base is 8. So we can rewrite it as 8. And the new exponent's going to be 3 plus 2, which is 5. So 8 to the 5th over 8 to the 5th. Now, at this point, we could say to ourselves, well, we have some number on the top, and we have the same number on the bottom, so that's just going to equal 1. Or we can use one of the properties and say, well, they both have the same base, and since it's a quotient, we can subtract the exponents. So we can write the 8 to the 5th minus 5, which is 8 to the 0 property, which anything to the 0 property, as long as the base is not 0, is going to be 1. So our answer is 1. Okay, the next example. We have 3 over x, and that whole thing is raised to the power of 4. So what we need to do in this one is distribute the exponent to both the numerator and the denominator. So we have 3 to the 4th over x to the 4th. 3 to the 4th over x to the 4th. And at this point, well, we can't do anything with the denominator because we don't know what x is. So we'll leave that as x to the 4th. But we can't solve 3 to the 4th, which is going to be 3 times 3 times 3 times 3. And 3 times 3, well, that's 9. And then the other 3 times 3 is 9. And then 9 times 9 is 81. Or you could have done it 3 times 3 is 9 times 3 is 27. And 27 times 3 is 81. You'll get the same answer. Okay, and that's the answer for that one. Now the next one, we have a to the 9th over a to the 5th raised to the negative 1 power. Now if you remember, when it's raised to a negative power, you just write the reciprocal. You write the reciprocal and then change the sign of the exponent. So the reciprocal of the base is going to be a to the 5th over a to the 9th. And our power is going to change from a negative 1 to a positive 1. And anything raised to a positive 1 power is just going to be the same thing. So we can just not write the 1. And then we can use one of the properties and say that a to the 5th minus 9, we can subtract the exponents. So we're going to get a to the negative 4, a to the negative 4 power, because 5 minus 9 is negative 4. And now we have a negative exponent. So we're going to, I'll just rewrite it down here, a to the negative 4. Now a negative exponent, again, tells you to write the reciprocal of the base and then change the sign of the exponent. So the reciprocal of a is going to be 1 over a. And the power is going to be 4. Okay, the power is going to be 4. And now we can again use our property and apply the 4 to both the numerator and the denominator and write 1 to the 4th power over a to the 4th. And that's just going to be, well, 1 times 1 times 1 times 1 is 1. And then a to the 4th, that just stays a to the 4th. Okay, now I'm running out of room here, so I'm going to erase some of that. But our answer is 1 over a to the 4th. So let's erase that and write 1 over a to the 4th. Okay, this last example, and I'll draw a line to divide it, and maybe scroll down and over to make a little more room. This one is a little bit more tricky. We have a product here. We have 4x cubed y cubed over 2xy times 5xy squared over 2y. Okay, how do we handle this one? Well, there's a couple different ways we can do it. We can treat these as separate fractions, or we can notice that everything's multiplied together in each one. We don't have any plus signs or minus signs, so we can multiply everything out if we want and write it as one big fraction and then collect like terms. So let's do that. We can write one big fraction. So we have 4x cubed y cubed times 5xy squared all over 2xy times 2y. Okay, now we can collect like terms. So we have a 4 and a 5 on the top. So 4 times 5 is 20. So you have 20 on top, and then you have an x cubed. Oh, here, let me circle some of these. So you have a 4 and a 5. Those are like terms. And then you have your x's. And then you have your y's. So let's count them up. You have, well, 4 times 5 is 20. Then you have x cubed times x. Well, that's going to be x to the 4th, because when you multiply powers, you can just add the exponents. And remember, any number that doesn't have an exponent written, you can imagine a 1 there. So it'll be x to the 3rd plus x to the 1st, which is going to be x to the 4th. And then y cubed times y squared, add those exponents, and you get y to the 5th power. So that's our numerator. Now let's look at the denominator. We have a 2 and another 2. So you have a 2 and another 2. And you have just one x. You have one x. And you have a y and a y. So you have 2 times 2, which is 4. And then you have an x and a y times y, which is y squared. Okay, that's our fraction. Now we can start to simplify. Well, look at the whole numbers. We have 20 over 4, which is the same thing as 20 divided by 4, which is 5. So 5 is in the numerator. Then we have an x to the 4th over an x. Well, we can subtract those exponents. It would be x to the 4th minus 1, right? Because this has a 1 there. So it'd be x to the 4th minus 1, which is x to the 3rd. And then we have y to the 5th minus 2, because it's y squared is in the denominator, so we subtract the exponents, and you get y to the 5th minus 2, which is 3. And that's all there is to it. That's our answer. So there could have been another way to work this out. This is just the route that I chose, um, and I think it worked well for us. You may need some practice with working with these, getting a feel for the different properties. But I hope these videos have helped you, and I hope you have a little bit better understanding of the division properties of exponents.